Well, hello everybody. What I need to do today is I need to cover section 6-1 with you. In chapter 6, we begin our study about optimization. We're going to look for more absolute maximums, absolute minimums. Last chapter, in chapter 5, we talked a lot about relative extrema. Today we're going to bump that up a little bit and talk about absolute extrema. It's really overall just a step up, a little baby step up from chapter 5. Now, chapter 6-1, it deals with the topic of optimization. We've been touching on this, it seems like, all year now. We're just going to turn it into a chapter today. People always want to maximize income, minimize costs. These are examples of the use of a derivative anytime we want to describe a rate of change. What I'm going to do with you today is I need to talk to you about absolute maximums and minimums. Now, there's not a lot to say on this graph. If you looked at it and I asked you to define or show me or point to wherever the absolute maximum is, you would just put a dot right there and you would say it's the absolute maximum because it's the highest point on the graph, and you'd be very, very right. So today this is called an absolute maximum because it's the highest point on the graph. It is still called a relative maximum also. So in this point it's an absolute and a relative maximum. Now, I want to point out here is a relative minimum. Now, that one's not an absolute because notice this graph is an open graph and it continues to decrease forever. So this is not the lowest point on the graph, but it's the lowest point in that area. Same thing here. We would still call this a relative maximum, but it's not an absolute maximum because of that point right there. Now, I'm going to also point out while I'm here, the maximum or the minimum occurs at the x value, but the actual maximum or minimum is the y value. So after we figure out where the max or min is, we have to plug that into the original to get back to the correct value. Now, what I'm going to do to you today is I'm going to take the graphs that we've been looking at, but today I'm going to restrict those on some interval a to b. So today they're going to become closed graphs. Now guys, when you think about a closed graph, the maximum and minimum can occur at a number of different places. So I've snipped 3 different graphs so I can talk to you about them. I'd like for you to notice that on this first graph, notice that the absolute maximum occurred at an endpoint, but the absolute minimum occurred somewhere within the interval a to b. And then I still have this other endpoint, but it was nothing to us. So my maximum occurred in this case at the endpoint, but my minimum occurred within the interval. Now think about a line real fast. If I restrict the domain on that, my absolute maximum would be there, my absolute minimum would be there. It has nothing in the middle. Has no extrema in the middle. So notice that my extrema, my absolute extrema, occurred at the endpoints of the interval AB. Now my last graph I wanted to show you is kind of look at that. I'm on an interval from A to B. I'm closed, but look at everything that's going on. My absolute minimum occurred right here, somewhere within the interval. My absolute maximum occurred somewhere within the interval. Now, what I'd like to point out real fast here is when we look at these graphs, based on what we did in Chapter 5, we can find the relative extrema based on calculus. Calculus is going to tell us this, this, and this. It's called the relative extrema that we did in Chapter 5. Find the first derivative, set it equal to 0, play the number line game. Now, today we're going to add in, we also have to check the endpoints to see if they're higher or lower than the absolute max or min. The steps will look pretty much the same as we've gone, guys. We're just going to add in one step. So an absolute extrema is either the largest or the smallest value in some interval, open or closed. A function can only have one absolute extrema. Now, with that being said, it can occur multiple times. If you think about the sine curve, notice that you have a maximum value, but you have it a number of times. But the maximum value would be 1. Now, I'm going to tie in today what's called the extreme value theorem. Here's what the extreme value theorem says. A function f that is continuous on a closed interval a to b will have both an absolute maximum and an absolute minimum somewhere on the interval. So we're going to look at different graphs today. We need to discuss the endpoints because in this example they would definitely be my highest points. But now some of my other graphs, guys, may look like that on my closed interval. Well, here would definitely be my minimum. Here might be my maximum. So we're going to have to look at the endpoints today, and I'll show you how we'll handle that. I've only got 3 examples because really you'll catch it right off the bat. So the extreme value theorem guarantees this. It guarantees the existence of absolute extrema on a closed interval. The key word there is closed interval. However, a continuous function on an open interval may or may not have an absolute maximum or minimum. Notice this open interval goes forever. Well, it definitely has a minimum but no maximum. So come over to your first example, and then I'll go through these steps with you and show you what we'll do. But to find our absolute extrema, these are going to be our steps. We're going to find our first derivative. We're going to then set it equal to 0 to find our critical numbers, and then we have to make sure they're in the interval for us. And then we're also going to evaluate the endpoints of A and B. And then it's kind of easy from there. The highest number is the max, the lowest number is the min. So here goes your first example. It says, state any absolute maximums or minimums for the function x cubed minus 3x squared on the interval from -1 to 4. So guys, step 1, we're going to find our derivative, and I'm going to get 3x squared minus 6x. We're going to do what we've been doing. We're going to factor this, and we're going to set it equal to 0 to get our critical numbers. In this case, my critical numbers are 0 and 2. Now, something happens at 0 and 2. We just need to see if they're a maximum or a minimum. Now, before I move on, I need to ask this question. Are the numbers 0 and 2 both in the interval that we're worried about? And in this case, the answer is yes. So my next step is I need to find f of 0, f of 2, f of -1, and f of 4. So guys, calculus gave me those 2 answers, the 0 and the 2. The endpoints may or may not contain my largest or smallest value. Now, anytime you want the y values, we go back to the original. So when I plug in 0 into the original, I get 0. When I plug in 2, I got -4. When I plugged in -1, I also got -4. And when I plugged in 4, I got 16. So guys, we found our derivative, set it equal to 0, plugged them into y. Now when I look at this, I got a tie for my absolute minimum. And right here is going to be my absolute maximum. Now, this point's still important. It's a relative extrema, but it's just not very important for me. Not very important for me at all. So there's my answers. Now, peek down at the bottom of your sheet, though. I want you to make sure you understand how Math Excel could ask you these answers. Let's use the absolute minimum from the example 1. And really, I'm going to use the absolute maximum because it was just a single one. The absolute max was at 416. A number of ways you could see this on Math Excel. They might say the absolute extrema occur at, well, you would just list the x values that they occurred at. They occurred at 2, -1, and 4, separated by a comma. They might ask it this way. the absolute maximum or minimum, I'm going to select maximum in this case. The absolute maximum is 16. That was the y value, and it occurred at x equal 4. You might see it as this, the absolute maximum or minimum, so I'm going to pick on maximum again, occur at, so you might also have it as an ordered pair. And every now and then you'll see it like this, the absolute, and it might even be a drop-down box, the absolute maximum is, and then we would type in 16, and it happened at x equal 4. So guys, those are the 4 ways Math Excel could ask you about your extrema. Here comes my next 2, and then we'll be done when done with the video. So on number 2, state any absolute maximums or minimums. So first step, let's find our derivative. So the derivative of 6x to the 2/3, bring that 2/3 down. Looks like I'm going to get 4x to the negative 1/3 minus 4. And I'm going to write this as 4 over x to the 1/3 minus 4. I think you'll see the critical numbers better when I do that. So one critical number for sure is 0, because I would have a 0 in the denominator. Now, let's go get the other ones. I got 4 over x to the 1/3 minus 4 equals 0. I'm going to add 4 to the other side so that I can cross multiply. So I've got 4x to the 1/3 equal 4. I'm going to divide both sides by 4 and get 1. I'm going to ask myself, what number could I take the cube root of to get 1? And my other critical number is 1. I could have also cubed both sides. So guys, my critical numbers happen to be 0 and 1. Before I move on, I need to make sure that 0 and 1 fall within the interval -1 to 8. And they do. So my next step is I need to find f of 0, f of 1, f of -1, and f of 8. So I'm going back to the original to type those in. So when I plugged in 0, I got 0. When I plugged in 1 for us, I got 2. When I plugged in -1, you get 10. And when you plug in 8, you get -8. Well, the biggest is your max, the smallest is your min. So here goes. That's going to be an absolute maximum. There's going to be my absolute minimum. And if you go back to the previous slide, we would just have to see how Math Excel asks for it on that. These are still important, but they're extrema. They're not maximums or minimums. And then guys, let me hit one more with you. State any absolute maximum and minimums for 5x over x squared plus 25 on the interval -6 to 6. Well, we need to find our derivative first. So I'm going to use the quotient rule on this. I'm going to take the derivative of the first times the bottom minus the top. Notice I left a little space there. So I've got the derivative of the top. I've got the top. I change that up. I've got the top times the derivative of the bottom all over the bottom squared. If we simplify the numerator, I got 5x squared plus 125 minus 10x squared over x squared plus 25 squared. If I simplify that, I've got negative 5x squared plus 125 over x squared plus 25 quantity squared. In the numerator, I'm going to factor out a -5, which leaves a x squared minus 25 over x squared plus 25 quantity squared. Now, let's go get our critical numbers. The denominator can never, ever be equal to 0 because of that plus 25. So I gain nothing from that. But the numerator can. I'm going to gain critical numbers of 5 and negative 5 from the numerator. So I said x squared minus 25 equal to 0. Well, now what I need to do is I need to find f of 5, f of negative 5, f of negative 6, and f of 6, my endpoints. So if we plug in 5, I'm going to do this in our heads. 5 times 5 is 25 over 5 squared is 25 plus 25 is 50. So I'm going to get 1/2 for evaluating 5 and negative 5. Now, if I evaluate 6 and negative 6, looks like in this case I'm going to get negative 30 over 51. 36 and 25. How about 61? And I'm going to get positive 30 over 61. Well, if we evaluate this, this is about 0.49. So here's my absolute max, and here's my absolute min. I forgot my negative sign on that. So my absolute maximum occurred at 5, and it was just 1/2. The absolute minimum occurred at negative 5, and it had a y value of negative 1/2. I forgot my negative when I plugged it in. So guys, that's the lesson. The steps that we'll do to find absolute extrema: find your first derivative, find your critical numbers by setting your first derivative equal to 0. We're going to find f of those critical numbers as long as they are in your interval. And then we're also going to evaluate the endpoints. So guys, that's section 6-1, your assignments on Math Excel. So good luck on that. Come in if you need any questions.